Hey Pre-Calc, in this video we're going to be starting Chapter 7, which is all about conics, conic sections, and our main focus today is going to be parabola. So let's start by saying what is a conic section. So a conic section is going to be the intersection of a plane and a cone. There are three types. There's parabolas, circles, ellipses, and hyperbolas. Today our main focus is going to be parabolas. Before we talk about a parabola, I want to show you a picture of how these come to be. So here you have a cone, and these dashed lines are going to be how a plane is intersecting. So if it goes straight across, we'll get a circle. If it's at an angle, we will have an ellipse. Bigger angle, we have a parabola, and going straight up and down, we have what's called a hyperbola. So we're going to start today's lesson by talking about parabolas. Now, let's start with the definition of a parabola, which is going to be a parabola is a locus of points in a plane that are equidistant to a fixed point, which we call the focus, point, and a line that we call the directrix. Okay, so let's make a picture to show you what this looks like. And you guys are familiar with what a parabola looks like, but you're not necessarily familiar with the term directrix and focus. Okay, so essentially we have a directrix, which is a line. I'm going to make a horizontal line for this example. It doesn't always end up being horizontal. Then I'd like us to make a point 2 above, and we're going to label that F. So in red, this is the directrix. So red, directrix. And this is our focus that I did in light blue. Basically, if we were to take a string and pin part of it to the focus and part of it to the directrix, halfway in between is going to create our vertex of the parabola. And then if I were to take that string and move it to the right and move it to the left, and it'll slide here but stay fixed here, we'll get a parabola. Okay. Now, the distance between the focus to the parabola is the same. So the distance from the focus to the parabola, so this distance, is the same as the directrix to parabola. So this is the same. And then say we have another point over here, the distance from the focus to that point and that point to the directrix, and my picture isn't super accurate, but this will also be congruent. And then it's going to continue to happen. And again, my picture's not super accurate, but right, because these are equidistant, and as we slide on the directrix, the distance is going to stay the same. Alright, so that's how the parabola is kind of made. It's made from the focus and the directrix. Now, another value that we should talk about is going to be the p-value, and that is the distance from the vertex to the focus and directrix. Is the p-value. That'll make more sense in a second. So this distance is p, and it's also p right here. Okay? Alright, so this is important. The p-value is important when we have the equation. So standard form of a parabola, there are two equations because it could be facing up or down, as well as to the left or to the right. So if it's opening up to the left or to the right, like a C, it'll be y minus k squared equals 4 times p, p is that p-value, times x minus h. If it's opening upwards or downwards, it will be x minus h squared equals 4p times x minus, or y minus k, excuse me. Okay, now a couple things to notice. H is always going to be with my x value, whether it's squared or not. K is always going to be with my y value, whether it's squared or not. And that's because h comma k is the vertex. So it makes sense that h is with the x values, k is with the y values. The 4p is always going to be with what is not being squared. So because this side is being squared, the 4p will be multiplied by the other set of parentheses. Now there are 4 types of graphs. The first type is going to be dependent on if it's x squared or y squared. So if it's x squared, you know it'll be opening upwards or downwards, and so then you have to look at your p-value times the 4. And if it's positive, then we'll be opening up. If you have x squared and p is negative, you'll be opening downwards. It's a reflection. If we have y squared, we'll be opening to the left or to the right. If p is positive, then it's going to be opening up towards the positive values on your coordinate plane. And if we have y squared and p is negative, it will be opening up towards those negative values. So x squared is like a quadratic, opening up or down. If it's positive, it opens up towards positive values. If it's negative, it opens down towards negative. Y squared is going to open to the right or to the left. If p is positive, it opens up towards positive values, and if it's negative, it opens towards negative values. So these are the important parts for that you need to understand in order to graph and solve equations. And in class, we'll do some actual practice using the equation.